Hello students, we are starting a complete series for class 10th ICSE chemistry. This series will help you to complete your syllabus for your board examinations. What we will be doing is we will be uploading topic wise lectures for each chapter, and after watching this series, specifically the chapters, the concepts will be at your fingertips. So let's start. We are starting with electrolysis chapter because this chapter is very important to build your foundation, and this chapter connects with each chapter that is there in your 10th ICSE book. So let's start. So what is electrolysis? What do we understand with the term electrolysis? What do we understand with the term electrolysis? Electrolysis. This term electro means electricity, and lysis means to break down, That means if we provide electricity to some compound, if we provide electricity to some compound, it will dissociate, hence it will break down into its individual components. Just for an example, if we take HCl that is hydrochloric acid, in solution, if we take HCl solution, what will happen if we provide electricity to this? What will happen after some time? This will break down into its component ions or individual elements. That means it will break down into H plus ion and Cl minus ions. So what is happening here? That is, electricity is playing a very big role in breaking down of compounds. Hence, we can say that electrolysis, the phenomenon of electrolysis, is establishing a relationship between electrical change or electrical phenomena and a chemical change. That means this chemical change is only getting executed just because of the assistance of electricity. So this chapter introduces a phenomena where electricity plays a very big role in dissociating things or in establishing a chemical change. Now we come to the substances. There are two kinds of substances. One is conductor and another is non-conductors. What are conductors? Conductors are those substances or elements or compounds that conduct electricity through them, or we can say that allows the electricity to pass through them. Non-conductors are those substances which do not allow electricity to pass through them or does not conduct any electricity through them. So let's classify those. First, conductors. Another is non-conductor. So we can say substances which allow electricity to pass through them. Just opposite to that, substances which do not allow electricity to pass through them. This is the first point and the major point. Next we come, why do conductors allow electricity to pass through them? Because conductors have mobile ions or electrons. Mobile means ions or electrons which can move from one place to another. The word mobile means movement. So conductors have mobile ions and hence it can conduct electricity. So what happens? It has another major difference is it has mobile ions or electrons That means if we provide electrical energy to this, the ions or the electrons will move from one place to another, hence conducting, making it a conductor. Next we come, these non-conductors do not have any mobile ions. Okay, so these do not have any ions, free ions. We should specify here, these it has free mobile ions. These do not have any ions or free electrons. That means we do not have free electrons in them. Okay. Next, the prominent examples for conductors are metals and alloys. So the prominent example for conductors are metals and alloys. Next, for this we have a prominent example of for non-conductors is non-metals. Non-metals are non-conductors. Non-metals. But exception, there is a single exception to this, that is graphite. Okay, graphite does conduct electricity. Exception is graphite. Being a non-metal, this infers that being a non-metal, graphite still conducts electricity. So this is a very important point, and I hope that you have already read this in your junior classes. Okay. So this is a comparative study between conductors and non-conductors. Now coming to the main terminologies of this chapters, that is electrolytes and non-electrolytes. Electrolytes, the term electro means electricity as we have discussed, and lights means substances or chemical compounds. Substances or chemical compounds that conducts electricity either in their molten state or in their aqueous solution. If we take an example like the common salt, the NaCl, what we have in our homes, if we make a solution of that NaCl solution, and if we make a setup or put an effort to make a setup of so that electricity can flow through them, or we can provide electricity through that, after some time we can observe that the solution is conducting electricity. Okay, so substances which can conduct or which can conduct electricity through them either in their molten state or in their aqueous solution is called as electrolyte. Substances which cannot conduct electricity in any situation, either they are in solid state or in their molten state or in their aqueous solution, they cannot conduct electricity in any circumstances. Okay, so let's recollect. Electrolytes, substances which let's specify substances, that means chemical compounds. Substances or chemical compounds which can conduct electricity either in their molten state or in their aqueous solution. Next we come to non-electrolytes. Substance, just everything opposite to this. Substances or chemical compounds. This chemical compounds must be emphasized because the chemical compounds participates in the reaction. Substances or chemical compounds which cannot conduct electricity which cannot conduct electricity either in their solid state, molten state, or in their aqueous solution. Overall, in any circumstances, they cannot conduct electricity in other ways. Next, the prominent examples of electrolytes are salt solution, okay, salt solution such as NaCl, then copper sulfate. These salt solutions can conduct electricity and gets dissociated. We will be discussing about the dissociation part later on in this chapter. Next, we can see the acids, the acidic solutions, acidic solution such as HCl solution, sulfuric acid solution, then nitric acid solution. So these can conduct electricity. Okay, next we can see the alkalis, or we can say the basic solutions, such as NaOH, then KOH, then CaOH. Here one thing must be made a clarity. I want to make a clarity in this. What is the basic difference between an alkali and a base? Alkalis are nothing. Alkalis are soluble bases. Okay, any base which can get dissolved in water or is soluble in water are alkalis. Okay, there are 4 alkalis which are soluble in water. There are 4 bases. In fact, which are soluble in water are these. We should make a list of this because this is a very important thing. It will help you in remembering the things in acid, base and salt chapter as well. So alkalis and bases. Okay, alkalis are soluble bases. Okay, and bases, what are bases? Actually, what are bases? Substances that release OH minus ions on dissociation. Dissociation means to break down. Okay, like if we take an example, like any compound which is having OH. Okay, any compound which is having or we can say the hydroxides, all the metallic hydroxides are bases. Just for an example, CuOH whole twice, then we have NaOH. Okay, then we have KOH. When we decompose, if we decompose these substances or try to dissociate these compounds, then we can get Cu2 plus OH minus. So then for this compound we can get Na plus and OH minus. For this compound, K plus and OH minus. So what is the common component, or we can say the ion, which we are getting after decomposing any base? That is OH. So any substance on dissociation giving OH ions is hence a base. But alkalis are soluble bases. So we must remember that all bases are not alkalis, but all alkalis are specifically bases. Okay, so soluble bases, such as there are 4 prominent alkalis. Other than that, all are bases. Okay, there are 4 prominent alkalis. These are NaOH, sodium hydroxide. Second is KOH, potassium hydroxide. Then we have calcium hydroxide, And another is, what is the similar thing we can get here? These all components, these all are metallic ions. Okay, these all are metallic ions. Exception to this, there is an ammonium ion even. Okay, ammonium hydroxide is even an alkali. Okay, this is a base and it can get dissolved in water. So coming back, the alkalis, the acidic solutions, okay, the salt solutions, the acidic solutions, and the alkali or the basic solutions. The alkalis, not the basic, any base which is soluble is only an alkali. So the alkalis, that is NaOH, KOH, CaOH and NH4OH, okay, ammonium hydroxide, these can conduct electricity in their molten or either in their aqueous solution. That is, if we make a solution of NaOH or if we make a solution of HCl, how can we make a solution? For making a solution, we need water. In that water, we will be dissolving HCl and hence electricity will be conducted. Now, the examples of non-electrolytes can be alcohol. Then we have this kerosene. Then we have this kerosene. Then we have sugar solution, sugar solution. Then we have petrol, okay, and etc. There are many more. So these are non-electrolytes that cannot conduct electricity in any way either, okay, either in their solid state, molten state, or in any aqueous solution. Now, electrolytes can be classified on the basis of two basic parameters, that is the conductivity, second their ability to dissociate into ions. So electrolytes can be divided. Electrolytes are classified on the basis of two parameters. The two parameters for the basis of classification is first conductivity, based on their conductivity. Second, their ability to dissociate into ions, into respective ions. Their ability to get dissociated into respective ions. Okay, based on this basic parameters, electrolytes are divided into two, that is strong electrolytes and weak electrolytes. Before proceeding, I want to clarify a few things. What is the basis of strong electrolytes? Now carefully observe this. What are strong electrolytes actually? If we take 10 gram of HCl, after providing electricity to this, if we observe that it is getting dissociated, first it will be dissociated into H plus and Cl minus, but that is the positive cation and negative anion. So it will get dissociated into H plus and Cl minus. And if we observe that this 10 gram of HCl is dissociating into 10 gram of H plus ions and 10 gram of Cl minus ions, we can conclude that these are strong electrolytes. That means the whole component or the whole mass is getting dissociated into its respective components, that is H plus and Cl. That is, none of the reactant, or we can say none of the mass of this component or this compound is still left, we can say that way. Then we have weak electrolyte. weak electrolyte. For an example, the acetic acid, what we have in vinegar, the acetic acid is a prominent example of weak electrolyte. See, if we have 10 gram of acetic acid, okay, after few minutes, or we can say after some hour, we can observe that after providing electricity to this compound, we can observe that though it is dissociated, because hence after all it is an electrolyte, so it will be getting dissociated into its components, respective components, that is H plus. Every acid, this is a very basic thing, that every acid releases protons, okay, protonium ion. Okay, this protonium ion, you can observe, this is the like we have observed that the common ion present inside bases is OH minus. The similar to this, all the acids have a common ion, that is the protonium ion, or the proton we say. And then CH3COO minus. Okay, this is the acetate part. So what we will be observing is, if we have 10 gram of acetic acid, it can be that only 5 gram of H plus ion and 5 gram of acetate ion is dissociated, okay, and rest is still left to get dissociated. That means weak electrolytes are those electrolytes that do not completely dissociate into their respective ions, okay, that is some or the other part is still left to get dissociated. But unlike in strong electrolyte, what happens, the whole component or the whole compound gets dissociated into their respective ions, and none of the component or nothing is left in the reactant site. So let's classify this. Now let's derive a differentiation between strong electrolyte and weak electrolyte. Strong electrolyte and weak electrolyte. Strong electrolyte and weak electrolyte. So as we have already observed in the previous slide, that strong electrolytes gets dissociated completely into the respective ions. Compounds getting dissociated completely into respective ions, okay, and here compounds getting dissociated partially, not fully, okay, not fully, like we have already seen that if we take 10 gram of acetic acid, it is not getting decomposed or dissociated into 10 grams of H plus ion and acetate ion. Maybe 5 grams gets dissociated, or 2 grams only gets dissociated. So we can see that there is a partial decomposition or partial dissociation, okay, so getting dissociated partially into respective ions. Okay, then this is the major difference. Then we have strong electrolytes allows the electricity to allows a large amount of electricity to pass through them. Though after all they both are electrolytes, whether it is a weak electrolyte or a strong electrolyte, all they are electrolytes. But in case of strong electrolytes, what happens? Strong electrolytes allows a large amount of electricity to pass through them, whereas weak electrolytes allow small amount of electricity to pass through them. So allows large amount of electricity to pass through them, here allows small amount of electricity to pass through them. And the third point, from the second point we can collect that these are good conductors of electricity. These are good conductors of electricity, and these are poor, though they will also conduct electricity, but these are poor conductor of electricity. Next point is very important, that is, for an example, if we make a setup, we take a container and we put electrodes. Electrodes are the terminals from where electrons are leaving the space. Okay, if we take electrodes and we take solution for a strong electrolyte. Okay, strong electrolyte. If we take a strong electrolyte, and if we connect a bulb to this setup, after some time, since these, if we take HCl, let's consider if we take HCl in this, HCl plus water, here HCl is there and water is there. After some time, HCl will get dissociated into H plus and Cl minus. Okay, and water will get dissociated into H plus and OH minus ion. What will happen is the Cl minus ion being an anion will act as an electron. Okay, and this will revolve in the solution, and hence revolving of electrons in any circuit will make the bulb glow. Okay, will make the bulb glow, but the weak electrolytes may or may not let the bulb glow. Okay, so it can make the bulb glow in a electric circuit setup, and here it may or may not glow the bulb in an electric circuit setup. And why is it so? Because we are not having sufficient amount of ions. Okay, the sufficient amount of ions is not getting dissociated here. For the prominent examples are all the examples which are already discussed, that is HCl solution, then we have NaOH solution. All the strong acid and the bases are good and strong electrolytes as well. Here acetic acid can be considered as weak electrolyte. Its formula is CH3COOH. Okay, this is acetic acid. So this was part 1 of the chapter. In the next video, we will be continuing with part 2 of this lecture, concluding this clip with a short motivational quote: face always towards the sunshine and your shadows will automatically fall behind you. Think about it. Thank you.